Welcome back, everybody, and off to Winter 20, Test 2, questions 23 and 24. LDA, we need to know because it's such a common, strong base. It's got a lithium cation, which I don't really care about, and 2 isopropyl groups. So it's lithium diisopropyl amide, and it's the conjugate base of diisopropyl amine. Those are conjugate partners. An amine has a pKa of 40. LDA is a strong base. Now we have to draw diethyl malonate with a group on carbon. Well, there's only one spot on malonate to put a group. We really have to know what malonic acid is in this segment. And on our test, malonic acid has OHs on each side of propane dioic acid, and an ester of malonic acid, like in this question, has ethyl groups on each side. The only position available to put a group, that's why there's no number in front of the group. The only position to put a group is on this middle position, and we have a 2-oxobutyl group, so I'm make sure I finish drawing a butyl group. 1, 2, 3, 4, and on carbon 2 we have this, and this gives us a variety of pKa options. We have a 20 here, alpha to a ketone. We have another 20 here, alpha to a ketone, and more importantly, we have a 10 alpha to 2 carbonyls. I hope you're getting the idea that being alpha to 2 carbonyls is a very important molecule on this test, because it's the third time I think we've seen it in today's review sessions. Okay, so the important thing is a pKa 10, and I think in retrospect I should have snuck this one on the last segment because it fits nicely with what we were talking about. So we need to know what the product looks like. Initially, it looks like this, but this is by no means the best resonance form. And there's an anion here. And remember, I just talked about why, if you're resonating, it's nice to be able to resonate with both carbonyls, but it's best to resonate, well, they're both esters. So I was going to say resonate towards a ketone first, but there's no choice of doing that. And if you think you can resonate towards that ketone in the oxobutyl group, then you're going through an sp3 carbon, and that just doesn't happen. So we have to pick a product that looks like what I'm about to draw up here. And let's just go with a green product. So we like an O- there, double bond, and 1, 2, 3, 4. So whichever product looks like that. And I think it's this one, CCCO-, CCCO- with an ET as well, and a CO2 ET here. And there's the oxobutyl over there. I'm liking E. I don't like this one. It has the double bond here. Not good. You took a 20 off to get there. This one, same story. I don't even see the carbonyl from the oxo, so this is just a wacky product. This one took it from the left side of the carbonyl right here. So no, don't do that. Don't do the 20s. or the unicorns before doing the best one right here. And pKeq, you take your 10 from the red acid that's on the left, EQ. EQ. 10 minus the acid on the right. I said 40 and I wrote 4. Yeah, that's wild. I want to point out pKa having a mean is 4T. If I go back and listen to the audio, I know it's going to be 4T, not 4. And yeah, we're going from 10 to 40. And that's pKeq. So KEQ, 10 to the positive 30. And I probably just have you show your work on this one. You don't have to pick an answer out of a lineup. And that's that. Let's move on and see if the other one's related to this stuff. Yeah, it's all pKeq. Let's stick with it. Okay, very similar to our last one. Yeah, LDA. That's this piece here. Her question, I think, was more about nomenclature. Don't forget, I'll just do an aside here that maybe will get her past it. If we had like isopentyl alcohol, 1, 2, 3, 4 with a V on the end, right? Isopentyl alcohol. Well, if you have isopentanoic acid, it's the same molecule at a different oxidation state. So same molecule. And I don't see an isopentyl group here. Don't forget the carbon of the acid is part of the molecule's name. So the name says 5 carbons, you better have 5 carbons. Isopentanamide better have 5 carbons. The name says 5 carbons. It doesn't say 6. Now, 1, 2, 3, 4, 5. If you added another carbon, it would be a 6. So yeah, that's part of the isopent right there. The V is as far away from it as possible. And it used to be isopentanoic acid and became isopentanamide, a derivative of isopentanoic acid. And I think that covered her question. And she's got another question. In chapter 4, when I introduced p-toluene sulfonic acid, it had a brief discussion about there's 2 other molecules that could be the same. P-toluene sulfonic acid has the methyl on the toluene as far away from the sulfonic acid as possible. Next one over was meta, M-E-T-A. It has the methyl there, and I'm just going to draw SO3H from now on. And ortho, O-R-T-H-O. Ortho. Oh, these are chloros. Oh, see what I'm doing? I'm not even looking at my stuff. I was stuck on the orthometa para. This is benzoic acid. It's not even sulfonic acid anymore. Meta means the 2 groups are on positions 1 and 3. Para means the 2 groups are on positions 1 and 4. And ortho means they're adjacent to each other. And these are chloros, I know. You're probably going nuts trying to follow this video right now. Just come back to this part right here. I finally have them all correct. Orthochlorobenzoic acid, metachlorobenzoic acid, and para-toluene sulfonic acid. That's definitely a -5 pKa. This is a 5, but lower with an inductive effect. 5, but maybe a hair lower than the previous one with an inductive effect. And para-nitrobenzene sulfonic acid. So if we have a nitro group, and I'll tell you something about nitro. If you haven't seen already, this is nitrobenzene sulfonic acid. Para meaning they're as far apart from each other possible. Nitro is a group that's going to become more and more important. So let's take a look at it. It's a nitrogen that actually has a positive formal charge. It, as a group, is more, think of it as a group that's more electronegative than a fluorine atom. I'm serious. It's much more electron withdrawing. And that's what electronegative atoms do, isn't it? They withdraw electrons from adjacent atoms. Well, this one does it more so because resonance and the charge both contribute to electrons wanting to go this way. So if you're comparing these two molecules, which are both sulfonic acids, and one that would really stabilize the minus charge of an O minus, even more so than a fluorine atom, then I'm saying, yeah, make the anion here, and this thing's even more stable. So I'm going to go -5, but lower because of the inductive effect, and that would be part of your answer, wouldn't it? So that would be the strongest acid of all of these. And I hope this is where I got motivated to do the first segment today, where we brought all the pKa's together. So we've got our molecule here, and I apologize, I cut off her carbonyls. And I think the answer to her question lies right here. Are you going to choose a 10 before or after a 20? When you're alpha to only one carbonyl, you're a 20. Taking that H off would make this a resonance form of this. So we can't mix these boxes up. These are not related to each other. This is related to a really better version and a slightly better version. And the two versions are the one that I wanted to see in the best resonance form box. Don't put what she put. Don't do that. In the best resonance form box, I want the one that resonates towards the ketone. And I'd like that a little better than the one that resonates towards the ester. So this goes here. If you're asked for a slightly not as good, but better still than the original, remember O minus is better than C minus. So that's the one I want over there. Okay. And we got that. And then we had on the same page of the same test, we're supposed to, let's see, there's a question in here. Propane sulfonic acid. So yeah, we got to know the sulfonic acids. We had one just a second ago. Those are all strong acids. And this one doesn't have a benzene, it has a propane. No big deal. That molecule would have a pKa a -5. All sulfonic acids, -5. Naproxen, 2-naphthopropanoic acid. Consider it benzoic acid pKa. You don't even have to get that cute with it. Just say it's close to 5, but a little down. Yes, and I liked what she said. Consider it just like benzoic acid. Here's benzoic acid. Benzoic acid has that and a benzene. And the only difference between that and naphthoic acid is naphthoic acid has another phenyl. They're called fused phenols. Naphthoic. 2-naphthyl propanoic, sorry. This is a popular analgesic. The sodium salt of it is anyway. And yeah, if you just said 5, but a little less for both of these. Okay. I had my hand on the screen. Why a little less? Well, the carbon attached to the carboxylic acid is sp2. So I'd want you to talk about that when you're comparing it to any of the ones where, like propanoic acid, sp3 next door is not as inductive as sp2. So that would make this and this better than propanoic. And then you talk about issues of hybridization for these two, etc. But I think she was okay with that. And I believe we're going to end this segment unless there's still pKa stuff lurking in the next one. No. Good old-fashioned mechanism coming up next. Nice place to stop. I'll see you very soon.